Good afternoon, everyone. A very warm welcome to today's session of the virtual webinar series of on LiFE, a program hosted by IISc. And we are gathering at a significant time, having just observed that World Aquatic Animal Day on April 3rd, and we are looking forward to World Health Day on 7th of April. And we are reminded every day that how deeply our health is intertwined with the health of our aquatic ecosystems. The LIFE program, or the Lifestyle for Environment program, introduced by our Honorable Prime Minister Narendra Modi ji at COP26, is a global call to reduce the mindless consumption and to move forward to mindful utilization. Today, we explore a fascinating pillar of the sustainable future, algae, often overlooked. These aquatic powerhouses are essential to circular bioeconomy, offering solutions that bridge the gap between the environmental health as well as human well-being. To guide us through this landscape, we are honored to have with us Dr. Durga Madhab Mahapatra, sir. Sir is an associate professor in the Department of Chemical Engineering at the University of Petroleum and Energy Studies at Dehradun. He is a renowned expert in environmental bioprocess with a specific focus on the water, energy, and food nexus. His work is at the forefront of regional sustainable development, utilizing green technology to turn biological resources into global solutions. Today, he will be presenting Algae for Life, Bridging Nutrition, Nutraceuticals, and Pharmaceuticals for Global Health. Today's session will delve into the transformative potentials of algae, exploring its role as high-value bioresource for both daily nutritional wellness as well as with the advanced pharmaceutical development. We encourage you to listen closely to the synergy between these indigenous resources and modern chemical engineering. Prepare your questions, and question answer session will be following the presentation of sir. Engage actively in the chat session as these questions will be discussed after the session. Sir, now the floor is yours. We look forward to your presentation. Over to you, sir.
Thank you very much for the opportunity uh, given by the organizers today for having me invited for the talk on this very auspicious of World Health Day 2026, which is on 7th of April, and also a part of it dedicated to the World Aquatic Animal Day that we just observed yesterday. Uh, because of to save a bandwidth, I'll just shunt out the videos and we'll carry with
Sure,
the
sir.
yeah, thank you. So, is the slide visible?
Yes, sir. Your slide is visible.
So once again, very good afternoon to everyone. As I told today, as we celebrate the World Health Day, we would like to align ourselves with the very rule which is written over here: "My health, my right." So this is where, we are holding on to a theory which is backed by science and equity. So despite a lot of medical advancements, we still face a foundational gap in the global nutrition today. So today we will be able to discuss on a momentous shift or a paradigm shift, where we are moving from the system, which is a unidirectional world, to a circular one that is reacting to the sickness. So we are most probably moving away from sickness and proactively building wellness. So the movement is from sickness to wellness with the help of one of the most evolved organisms on earth, that is algae. So at the heart of this type of transitions that is being witnessed today in the globe, we would like to also give a new nomenclature to algae as the green gold of the 21st century. It's not just a microorganisms or a miniature plant. It is today scalable, and this would help in decentralization and democratization of health for every citizen on earth. So we'll go through briefly the agenda for the day. So we have divided the talk into several sections. So each of these sections would have its own examples. So start with the initial part, which is to make ourselves acquainted with the global health. What is the present reality, and why do we need to look forward to certain natural organisms like algae? So here we bring in the very historic and our ancestral perspective from Indian knowledge systems, and we'll also look at how our science that we practiced long back was also giving us a lot of information and remedies with the help of algal technologies, which was then called Saivala Sanjeevani. Then we will move on to look at the very physiology and the metabolism of algae and how it is one of the most robust biological platforms, which is going to empower our multi-trillion dollar economy or the bioeconomy to the next phase, and where we would be the center to the world in terms of global supplies to meet the global demands. Then we'll look onto the aspects of algae where it gives food, feed, and nutritional security, algal nutraceuticals and pharmaceuticals. Here we are going to touch upon one of the very interesting and the first of its kind of a scalable study that we did in Mysore, where we will be discussing our experience on Vipuram farms, where we were not just able to monitor and have a surveillance of the growth of algae. So the first of its kind of a study which were demonstrated in hectare scale at IAC. Uh, then we will move on to see that how algal knowledge on nutritional quality, nutraceutical, pharmaceuticals are together helping us to strive over the demand, which is to a translational pipeline, and what are the local and the national bodies that regulate such type of products to be available to the customers in the market. And finally, we'll look at scope of such type of algal medicines or algal remedies through an industry platform, the potential of such kind of economy for its contribution to GDP, and making us, the leaders in global leaders of the world, where we look at scale up, technology, and commercialization. And finally, we'll close our talk with a particular roadmap which shows 21st century advancements in algal sciences and a couple of recommendations that we need to follow for the future. Well, so these particular slides gives us an idea about a balance or a sort of a balance that has been weakened at one end. Whereas currently we are fighting a war on two fronts. You could see in the left hand side, we have the hidden hunger, which is malnutrition, deficiencies, which is affecting around 2 billion people. On the other hand side, the right to me is a tsunami of NCDs, which is non-communicable disease like diabetes and cancer, which is now nearly, you could see 1/3, like 3 out of every 4 deaths worldwide are because of diabetes and cancer. Earlier, it was mostly communicable disease which were responsible for highest number of deaths that were witnessed. So what is very important is that you could see these are paradoxical, where we see both extremes of malnutrition at one end and obesity, which is at the other end in the same communities. Sometimes you could see both extremes in the same families or households. So our very mere knowledge of agriculture to body or the soil to self agricultural model might be very slow these days, where it is largely resource intensive and really cannot address this burden at present. So what we need today is a faster and a deeper biological intervention. Now, when we talk about interventions, so we have a limitation in the current health strategies that we follow. So when we see we can't, see the systems running because like such systems get easily exhausted. To produce, let's say nutrients to combat malnutrition, to produce a traditional animal protein, we use a lot of resources, which is land, water, which is required for a lot of different types of. Meanwhile, our pharmaceutical industries, they have been doing extremely good and have massive environmental footprint. However, we could also see these pharmaceutical industries also struggle with the side effects of synthetic molecules and health hazard because of exposures of such harmful chemical radicals to human beings. So could be in terms of skin exposure or olfactory exposures or exposures to eyes and so on and so forth. So now we have historically treated food as fuel and medicine as cure, as you could see here, and there is a missing biological link here. So here the fuel and the medicines are the cure, keeping all of these things in silos. So today what do we want to mostly think is, can we re-establish the biological link that bridges the gap of where we have a resource scarcity, and we will also have an organism that could give us a better therapeutic efficacy. So this gives us an idea about venturing into newer areas or organisms that have this type of potential. So we are talking mostly about algae today. So why algae? So this is one of the most interesting interventions that is happening. We could say that these are the ones which have been called Saivala, which is 5,000 years of observations of wisdom. So you could see that this has been written in Charaka Samhita and a lot of other places. Susruta and Charaka, they noted like these particular organisms to be having Sitavirya, so which is called a cooling potency that balances an aspect called Pitta by a systematic anti-inflammatories. So this is Saivala, and you could see that they have been witnessed to found in stagnant waters. So this also gives us an idea to venture into the nature and find out whether such organisms could be of any help today. So now we have in parallel the algae or the Saivala that has been encrypted in manuscripts which have aged back to centuries, to today's modern day examination of genomic sciences of algae, of all what informations they encode. Do we find a parallel? Of course we do find them. So this is in case of the highest order of the metabolic transcriptomics, where we could see that thousands of genes that are responsible for a plethora of compounds that might be directly or indirectly beneficial for health of the environment and to regulate health of the organism. So as we also told that yesterday we just observed and celebrated the aquatic animal day. So this is where algae stands as a primary source of energy for all what we see. So if we say fishes are very good for health because of higher omega-3 fatty acids, the fishes are just accumulating or hyper accumulating omega-3 fatty acids, which is present in algae itself. So if you look at the type of the pyramid that is being given here, we have an upward flow of energy from the very basic or the primary sources of oxygen and food reserves, that is algae. So in this particular plot, you could notice that this algae in these water systems that have contributed substantially to generation of oxygen, which is around 50 to 80% of the Earth's total oxygen. So we were under an impression that trees do contribute to oxygen. They do that. However, if you put all the rainforests put together, they just contribute around 20% of oxygen. So you could see how important is algae deep down in this type of aquatic food web, which is the basis and the foundation of food, nutrition, and so many major compounds which is there. As you rise up in the pyramid, we have phytoplanktons, zooplanktons, and then we have the fishes, small fishes, and the large fishes. So this is the aquatic food web that we see, and in these cases, some way or the other, algae and lower plants have been the essence or the primary energy sources for most of the kind of the trophic levels that we see. So here, algae, which is phytoplanktons, are consumed by zooplanktons, and then by carnivores, and finally by the large fishes. So we could see the entire pool of food that is passed on from one trophic level to the other. Now, if we look at the parallels that we draw between the algae, which is one of the most oldest organisms on Earth, and also the algae, which is cyanobacteria here. So they have tremendous amount of importance great amount of significance, and today they are the basis of nutrient recycling or cycling. So algae do absorb excess of nutrients from the atmosphere as carbon dioxide and dissolve nutrients like nitrogen and phosphorus from solutions. And that is how they regulate the nutrients in both, you can say, earth, water, and air. Secondly, they are very good in terms of habitat creations, where you could see these are the kelp forests, which is seen in deep waters, in marine systems, where you could see this is like jungles, where the kelps could be from 50 to 100 meters in length, thronging from the bottom of these type of oceans. That gives a feel of like rainforest inside oceans, which is a host, or which is actually the habitat to numerous aquatic organisms. Similarly, they are most possibly the economic backbone of our country or for the entire globe, is because of its primordial design of production of metabolites. So algae being the basic energy source are also the essence of inland and marine fisheries, and therefore billions of dollars that we earn because of such type of trade and commerce is possible through algae. And finally, the greatest amount is the type of the biodiversity support, where it is backing every organisms directly or indirectly, being at the preliminary levels of the food chain. So a healthy ecosystem is only when we have a large and a healthy diverse algal population which is present in the system. So, well, as I was like telling you, algae are important is because they are one of the most profound architects that have been generating oxygen. So if you look at algae are considered the lungs of the earth. So these are the oxygen architects of our planet that are responsible for every second breath that you take. So if you look at these type of algae, which could be chlorella to massive deep kelp, so they are nature's most efficient energy converters. Although you could see plants like corn also are very efficient carbon dioxide fixers. However, they are having better roles in terms of food security, whereas algae becomes the base of the pyramid for energy flows. Whereas these corn or plants might require a large piece of land, algae can double their biomass in hours, even at extremes of environment like salt water, alkali water, or acidic waters, and even wastewater or vertical surface. Therefore, today we are looking forward to algae. They don't just compete with our food crops for land. Instead, they turn the waste and sunlight into pure biochemical wealth. So this is what is we have witnessed with algae. And you have tremendous diversity, over 30,000 species ranging from single cell microbes to giant kelps. So that is what, and they have been like astoundingly working together to convert bulk of this carbon dioxide to biomass, which is fixation, which is one of the important ways in which we generate biomass and earn revenue out of it. Well, if you look at the intricate architecture of algae, you'll be mesmerized with the way the things are packed up so densely. So in this case, if you look at algae could be treated as living biorefineries. So we would just want you to stop thinking algae as a nuisance or a pond scum and see them as modular factories. So these are single cell algae which is actually having a lot of high quality proteins. You know, we can say, you could see a lot of advertisements today, heart healthy omega-3s. So these healthy to heart omega-3 fatty acid sources are algae. So these could be treated as secondary treasures for a lot of important pigments like astaxanthin and phycocyanin, which are one of the most important antioxidant, anti-aging, and anti-cancer agents. So this is where nutrition and pharmacology is mostly done with algae. So these are some of the organisms which are the base for the type of the food that we take today. So the SCPs that you take today, the protein shake, the daily vitamin requirements, and this also becomes a potential lead compound or API to several vitamins. You could see here the cytoplasm. If you if I take sections of each of these layers, you could see there is an integrated role of each of these for providing primary for, you know, like the cytoplasm contributes to omega-3 fatty acids. The chloroplast are actually sources of pigments, and you can see the cell wall, which are important dietary fibers, and which are the sources of bioactive peptides. So look at the very nature of the architecture that is being built. So this is unusually dense with a lot of metabolites that are important as food, feed, nutrients, pharmaceuticals, and nutraceuticals. Now let's have a comparison of the so-called proteins that we found elsewhere, which is the traditional beef, the red meat, the soy, the soybean cultivation, and compared to microalgal protein. Here you could easily see, whereas you have a protein yield of 1 to 2 tons per hectare for both beef and soy, it is up to 20 tons per hectare. So it is roughly like 10 times higher protein yield. In case of water consumption, if you want to grow dairy, or if you want to go for cattle, you could see they have a massive footprint and a land footprint similar to do with agricultural crops like soy. However, 99% less water than the beef or the soy is required for every kilogram of production of protein in case of microalgal proteins. Now, when it comes to like resilience or climate adaptability, you could see that these cultivations are highly sensitive to environmental extremes. They are more vulnerable. However, microalgal protein, because of its super photosynthetic machinery, might be impervious to these type of threats. So they do thrive in controlled and closed loop systems. So this is a comparison of like protein density. You could see eggs, beef, spirulina, which is one of the most rich protein sources today. So this has been also endorsed by NASA as one of the superior foods for astronauts, chlorella and spirulina, because of its higher fiber, protein, omega-3, and all other supplements. You could see that the protein density is as high as 70% in case of spirulina. So this also gives us an idea about the completeness of algae in terms of its contribution as single cell proteins. So when it comes to bioavailability, these algae, because of their very architecture, are also a source of plethora of micro and macronutrients. So they have a higher concentration of vitamin B12. They act as critical natural plant promoters, which is important for those who have plant-based diets. And of course, they actually provide a better nutrition than conventional bacteria or yeast-based single-cell proteins. So because such type of proteins are devoid of nucleic acids, because nucleic acids digestion in the gut is very difficult because of lower enzymes that are found in the gut. So therefore, the risk of food poisoning, indigestion, and palatability is much lesser when we take algae as a single cell protein compared to the others. You could also see this particular graph where you can see that how is the micronutrient absorption happening when we take spinach iron and algal iron. You could see that you have tremendous uptake of algal iron compared to spinach iron. So that means the iron compound in algae is readily dissolved into the bloodstream compared to spinach. So this gives a superior iron content and a dissolution of iron content from algae compared to even the richest protein plant source, which is spinach. Well, today we are where we are look around the urban farming, where the urban infrastructure could readily convert carbon dioxide into algal biomass, fixing carbon and generating a lot of oxygen that is important. So today we are thinking that can we contribute to the demand of carbon fixation, where we could actually have a potential of around 10 billion. This is where the mechanism, which is very important, is like you have algal infrastructure in megacity buildings that helps in high yield bioreactors. And this would be immune to any type of climate and provide coolness and stillness in many of these, where our food requirements are no longer just dependent on water and agriculture. And this actually helps us build a lot of food in these type of captivities. The nutraceutical transitions. So as we witness, uh, here you have phase one, which is where we have a lot of sickness that is there, that is done with the help of algal treatment. So you have a lot of compounds that are there which helps in taking care of this. You have siloed nutrients which is there. This is traditional pharmacological based techniques. And in phase 3 we have the algae, which is the missing link that is integrated into the drugs through the help of APIs, which is both providing nutrients, are preventive in nature, and sometimes when they are purified, they are actually having high yield, which is US pharmacopoeia grade. So these are some of the standards which is followed globally for drugs. That is very, very important. So now we come to the very essence of algae for life, where we look at from an Indian knowledge system perspective. So this is where we are trying to see insights from our ancestral wisdom, which have used algae in the conventional alchemy, which is Rasayana Shastra. So algae has been very prudently used then for several kind of formulations and were used earlier. So we are going to have a look at these type of instances and we'll brief them up here. If you look at water as a source of universal medicine, so you could see that these algae were conventionally known as Jalapuspa or Saivala. So this is the primordial system wherein we have this type of Jalapuspa, the flower-like structures, where you could easily notice green color chloroplasts over this. So it wasn't just a vegetation, it was recognized by like Ayurveda, Siddha and Unani systems for its detoxifying powers. Most importantly, the IK's view views algae to the philosophy of Vasudhaiva Kutumbakam, where algae has been made for the goodness or to impart wellness to everybody, where the world is one family. So this means we treat algae as a shared heritage for the collective well-being of humanity. Now, this is the periodic table you people might be acquainted with. So algae is actually a nutritional powerhouse. So today, if you go to Europe, you could see they are customized superfood. So when we say superfood, means you can just live with the tablets of algae. So we have one of the projects with a collaborator from INL Braga from Portugal, where they are making customized 3D printed algal superfood, so which could be shaped up for whatever is the customer's demand. So you could actually have Marvel characters like Captain America or the Hulk as so our lab looks at giving the type of the formulation and they put it as 3D printed materials, and that is how a lot of demand is being made for algal superfoods in Europe. So in this particular periodic table, what you could see is that algae could be the superfood of us of this particular century, where it carries 54 trace minerals. You can see a lot of trace minerals and massive amount of vitamin B12 and iron. So from an IK's perspective, this we call it as a sattvic food. So sattvic foods are those that bring in a lot of purity, agility, lightness and balance to the body, which wakes up the prana, which is the internal energies to combat dosas. So in this case, you could see that it is not just about like counting calories, but it is about the life force or prana that is energized with this type of nutrient dense organisms. Well, when we look at India's relationship with algae, it does not confine itself to books, but the various geographical regions and the biogeoclimatic platforms. So, right from Arunachal Pradesh, the Monpa tribe, they have used freshwater algae for generations, uh, all to the coasts of Tamil Nadu and Lakshadweep, where seaweeds have been used. Seaweeds like Gracilaria have been used for making halwa, to medicinal porridges. So this heritage that gives a sort of a testimony or is a proof that algae has been safe conventionally and traditionally, has been used as a functional food in Indian diet for centuries. Now, when we talk about algae and its connection to nutrients, we are now entering a very critical dialect where the food meets the medicine. In Indian knowledge system, we call this bridge between. So, if we say this is actually a balance between algae and the type of the medicines. So, it is bridge between ahara, that is diet, and ausadha, that is medicine. So the molecules, like as I just told earlier, astaxanthin and phycocyanin, which are naturally pigments that are found in algae, are the nature's most potential antioxidants and anti-carcinogenic agents. So they are one of the perfect nutraceuticals. They not just provide health benefits, they go much beyond that by from nutrition to manage conditions like diabetes, a treatment for Alzheimer, epilepsy, immune deficiency, and so on and so forth. So you could see that how algae has been very, very important for targeted therapeutics, be it polysaccharides, carotenoids, or phycocyanin. And they have a lot of other clinical outcomes which could help us with weight management, immune boosting, sugar management, so on and so forth. Now, this is where we talk about the circular economy, the pharmaceutical evolution of algal biomass, wherein with this type of diagram, we validate that the ancient texts which were written by, Susruta, who was one of the pioneers in medicine, he gave a lot of formulations on these algae, where we see algal compounds being used for neuroprotection and as scaffolds for wound healing. So this is the journey of some specific molecules. So this was done, I think, with the prehistoric algae, which is sargassum plant. And today the same algae sargassum has been tested and has been run through clinical trials for drugs, and is a perfect example of how ancient wisdom, could serve as a lead for modern drug discovery. Now let's look at uh, how do we go about the algal diagnostic matrix. So this is where we need to do a tridosa balance, which is very, very important from the algal diversity and the varicity of pigments that are present in algae. So here, as you could see, we go forward for some of the focuses on tridosa, that is vata, pitta, and kapha. So algae preliminarily is supposed to add sitalata or cooling behavior. So this is where the red algae, which is very, very important, is actually used as a neuroprotection agent, and that advanced structural scaffolds. Pitta is actually a particular type of dosa that could be balanced by the intake of mostly the brown algae and to an extent the larger green algae, which is to do with cooling down or reducing the inflammatory responses. And kapha, which is mostly to do with excisions or mostly to do with detoxification, is mostly through the green algae, which is where you have a better skin care, better management of skin, where we have a lot of cleansing protocol taken into picture. So this balance between vata, pitta, and kapha is very, very important from an IKS point of view, where people look forward to such type of matrices for a better health and a better agility. Well, so the zero cost environmental input equation is very, very important here. So here, so Indian knowledge system teaches us that how close are we to nature or prakriti, that is living in harmony with nature. So algae is one of the ultimate sustainable crops. It requires no land, no pesticides, and of course respires with carbon dioxide, that is a toxin to many, or carbon dioxide, which is one of the most important GHG, which is the reason for such disasters that we are witnessing today. So today, through the Prime Minister's various climate combat schemes, India is today looking at empowering coastal women to farm seaweeds. And this particular occupational health also makes sure that at the customers end, people are having greater benefits for in terms of health. So it's health for the planet, and thus such type of augmentation in revenue generation would actually enhance the blue economy, or the economy that is generated from marine resources. So this is where we look at the connection between Anu and Paramanu, and it takes all the way to Atma and Paramatma. So this is where the very cell, how it is getting connected to the tissues, to organs and body, and how this body is connected to the planet is actually validated through the nutrient cycles, and algae being one of the important messengers for carrying out such type of nutrients. So in this case, we look ahead of challenges like bioavailability, standardization, and preservation. So this is where we have to look at how do we bridge such type of things together, where we want to connect the clinical part or the advanced pharmaceutical part with the old traditions and the use of such type of algal compounds with the help of the tribal, with the knowledge and wisdom of the tribal people. So we are looking at improving systemic absorption by the bioavailability studies. We are looking at improving the purity of the compounds, the way they are harvested and extracted through QA/QC protocols, and then ethnobotanical documentation, which is also very, very important. So in this case, we must ensure that algal nutrients are easily absorbed by the body and that our products meet global quality standards. Most importantly, it is important to document the oral traditions of our tribal communities, like before this indigenous knowledge is lost to history. Well, anchoring global health in ancient wisdom. To sum up, algae is more than just a plant. It is a global health, you could say a sort of a global health insurance. Nothing works, algae works. So by integrating Indian knowledge systems with modern sciences, we not just enhance our understanding of pharmacopoeia, but also this meets the requirement of United Nations Sustainable Development Goals for a better health, hygiene, and well-being. So this is high time that we embrace such type of ancient wisdom for a sustainable future. So this gives us an idea of the practicality of algae as one of the most purest nectars, or we can say amritam, which is the Saivala Sanjeevani. This is very nicely encrypted in some of our scriptures earlier. So this dates back to the type of the text that have been found in with Bhava Prakasha and Charaka Samhita. So where this particular nomenclature of Saivala came into being, which is mostly lower plants or algae. So they were also oftentimes uttered as Jalapuspa, as I told, and they would impart a lot of different types of properties. They have balancing abilities for this Rasapanchaka, which is Rasaguna, Virya, Vipaka, and Prabhava. So in this case, these balance out the human metabolism by taking care of different kinds of potencies, as you can see from this very cycle. So the very first pillar is the nutrition or pathya, which is the entire food. So algae as a superfood is not a new knowledge. It was used from time immemorial as a macronutrient, which is one of the highest protein content. So this is where it is called brahmana. And this was one of the perfect nutritional sources earlier, with a better digestibility, and gives one of the best sattvic diet ever. So then it comes to rasayana for systemic rejuvenation, where you have a lot of different types of potential that gets built up in. So as you would see, this is anti-aging potential. You have metal or trace element type of vitality, and you have ojas building, where this is the very vital energy that goes from lower nodes to higher nodes as we delve into this type of sattvic aharam. And the third one, which is where you balance out on the various glands in the body, which is to do with the pituitary, the thyroid, and the lower glands. So where you have a systematic balance that helps in, adequate digestion, burning of food materials, regulating thyroid, uh, which we say galaganda. And then it also gives us a lot of nourishment and refreshment for the entire body, where each cells, tissues, muscles, bones, and the skin actually glows. So this is actually known as akshata, which is rakta prasadana, which is blood as a blood purifier, and helps in the overall healing of the body. So this is where we can think of developing algae based on the foundational knowledge of Ausadha, which is in Charaka Samhita. And we could see a lot of different types of nanotechnologies evolving from algae, which is the bhasma, or the advanced formulations, where you actually char algae unless it becomes nanoparticles. So this is called the Sharavigyana, or the alkali science by the alchemy, where some of the specific seaweeds have been processed into alkali, and these have been used for surgical usage, and that has been improving effects on clearing metabolic blocks. The calcareous algae, like the ones that we notice often in the 2 nautical miles away from our, like the coasts, which is both east and west coast, they have been used for various types of calcium augmentations, be it coral or sankha, and all. So our daily practice of using this helps in doing that. And finally, we have alginate today, which is being used as agar, or one of the important gelling agents. So this is actually were used as carriers, which was then used for drug delivery. So today we use various polymers made out of these type of algal carbohydrates. You can have sulfated polysaccharides that have been used for a lot of different types of diagnostics and treatment as herbal medicines. Well, so this is where we go hand in hand with what are the validations based on the modern sciences, and what are the Ayurveda contextual claims. So the very property of Vrananashanam, which is wound healing, is based on, it has been validated with alginate based wound dressings. So it was then written in Sushruta and Charaka Samhita, which has been validated as on today. The Raktapita, which is bleeding disorder cure, has been again validated from sargassum's high vitamins presence, potassium, and coagulating properties. And then the traditional antiviral, anti-inflammatory, and immunity claims have been also validated with sulfated polysaccharides that have been found in marine organisms. Well, so this is at a micro level, at a level of a body, as we told. So the primordial organism, which is everybody's ancestors, so these are algae. If you draw a parallel between algae and cyanobacteria, so the primordial organisms that were our ancestors, or the plant's ancestors, were once cyanobacteria. 3.5 billion years ago, they were responsible for changing our Earth's atmosphere from reducing to oxidizing. And that is how life came onto Earth from oceans. So this algae, which is actually sharing chloroplast with every plant cell today, and a variant of it, which is a mitochondria, is being shared by every animal cell and us. So you could say that algae could be considered as ancestors to both animals and plants, and therefore a deep connection between us and this algal metabolism. So it helps in elemental resolution, where algae actively restores balance between jala, which is water, and earth, which is prithvi. So algae also helps in minimizing or cessation of waste, which gives us an idea of the zero waste systems, which is the entire the routine clearing of the planet through the panchanga. And then you have very ways of using of this algae, which is ethical harvesting, where we have the very climatic patterns that come into being as rutus, and this gives a very idea of the balance and harmony of nature in different seasons and the growth and diversity of algae, as you could see. So therefore, the global vision is for health resilience, which could be dreamt of when we use such kind of saivala in. So it could give us a lot of ideas on reverse pharmacology. We are going back from drugs to find out whether it could actually evade symptoms. So moving from ancient Ayurvedic observations to see that whether we could actually recreate this in modern laboratories and accelerate pharmacopoeia or drug discovery. Here, Saivala could be also used as medicines on everyday basis, which is called dinacharya, daily routine nutrition. And finally, you could also see that bridging Indian traditional wisdom with modern science actually gives us a great grip on modern health sciences with a resilient and a sustainable future, which is also UN-based sustainability development goals for a better health, hygiene, and a livelihood for the people to follow. So now we will go to the context of how are we looking of advancements of algae as nutrients. So when we are connecting these nutrients to the pharmaceuticals. So here we would like to show you that how various ingredients of algae have been used today for a pharmacological interventions. We talk about the marine bioactives, so phycocyanin, astaxanthin, marine polysaccharides, and complex fibers. So these have plethora of uses, as I mentioned some of them earlier. So they could be used, sourced from spirulina, from Hematococcus. The type of seaweeds that we observe in marine systems have significant health benefits that is being laid, and are sometimes one of the best gut regulators for food. Well, this gives us an idea of also looking at the mechanisms for health action. How do these molecules actually work in a human body? So they function on a systemic level. As you can see, oxidative shield that neutralizes free radicals that lead to DNA damage. And perhaps more importantly, they flip the inflammatory switch by down-regulating pathways, as you can see here. So instead of, so this is that the pathway which is responsible, and almost it is actually rooted to every chronic disease today. So such type of pathways could be blocked. So unlike silver bullets drugs that were once upon a time used, so today bioactives from algae can actually give us an edge in polypharmacology. So they balance the system with a remarkable low toxicity. Now, when you look at the clinical evidence, this very well validates the nutraceutical impacts. As you could see, so science is only good if it could be witnessed or if there is an evidence. So when we are, looking at the type of the mechanisms of health action, so here we look at, can we anecdotally, look at superfoods that claims that we are controlled by these type of algae, and how are these trials being made? So in this case, you could look at the health impacts, the heart health. Spirulina actually gives a lot of reduction of LDL, which is bad cholesterol, and triglycerides while managing blood pressure. You can see glycemic control, where algal fibers gives a better glucose absorption, which is very, very important. And you could see that over like months or years, HbA1c levels have been stabilized in case of type 2 diabetes. And you could see that when there's a regular intake of algae and the pigments, it helps in cognitive processes, a better vision. So pigments like astaxanthin helps in better memory, cognitive behavior, and also helps in reducing fatigue in olfactory areas, and helps in balancing of um, or improving upon the eye power. So here gives this particular evidences have shown a better nutraceutical impacts of this algae. Now, as I was telling earlier, people look forward for fish today, which could be contaminated or hyper accumulating a lot of. So fish do accumulate omega-3 fatty acids. It also do accumulate a lot of heavy metals. So it gives us a particular area of caution that we should actually pragmatically look at these type of sources, check its authenticity as a nutrient, and then have to ingest it. So in this case, algal solution is a better option, 100% vegan, zero heavy metals. So, and then you have so there is nothing which comes from staleness here. So in this case, if you look at a comparison, we have an equivalent. A ton of algal oil saves 60 tons of wild caught fish. So that also helps in increasing the fish diversity in aquatic systems. So now this is actually an increase in the complexity and the regulation here. So start with, we have supplements and nutraceuticals. So where algae could be taken unprocessed, unpurified in bulk, which acts as a broad spectrum, helps in utilizing a lot of bodily requirements, and this is where holistic extracts are possible. To the next purified level is the active pharmaceutical ingredients, APIs. So here one has to isolate algae. They have to isolate the specific chemical scaffolds. It could be halogenated compounds, sulfated compounds, which are very unique to marine environments, and they are available to land plants. And finally, at the higher tier, you have advanced delivery systems, which is, so we say it pond to pill. So algae from ponds, where algae could be integrated or algae could be provisioned for a nanoparticle based high precision wound healing through the help of different kinds of gels. Students with us are actually working on algal gels for miscellaneous applications. When we compare, you could see that algae has also been witnessed to reduce a lot of oncological disorders. So it actually starts apoptosis. Cyanobacteria derived cytophysin forces cancer cell to stop dividing. So here one could say that it's a regulated regulated cleavage that is being done just to make sure that the cancer is stopped. So here they have proven efficiency in a lot of cell lines, like the liver cell lines and the breast cell lines. In terms of virology also, we have witnessed that sulfated polysaccharides have a dramatical role around improving upon the resistance to viruses and blocking the spike protein so is a lot of molecular studying of molecular modeling and drug designing or protein docking. So wherein a lot of these type of drug compounds have been responsible to stop viral. To an extent, a lot of such type of drugs were also developed during the COVID times. So these areas of research gives us enough evidences for therapeutic usage of algal bioactive peptides and many other molecules to tackle complex diseases. Now, when I say that we have modern metabolic syndromes, and algae could balance out on each of these. So be it diabetes management, hypertension relief, or lipid metabolism, you could see that algae provides polyphenols that inhibit alpha amylase and therefore can stabilize blood sugar. You have hypertension relief, which is due to the natural AC inhibitor that is responsible for the the widening or the constricting of blood vessels without any type of synthetic effects. And of course, because of a presence of better omega-3 fatty acids and epigenetic activation of fat burning genes, this could directly help us with weight management and lipid metabolism. Well, now let's look at the type of the translational pipeline. When we say translational pipeline, is that the understanding is sufficient for us to get into holistic integration of such type of bioactive molecules together to make a superfood or a particular pharmacopoeia that could be used directly as a food, feed, nutrient, nutraceutical and pharmaceutical? Of course it could be. So this is the particular way, from lab discovery to bioprocessing to preclinical trials to clinical trials and market integration. It is a strategic way in which we actually go for a crude extract to an algal derived API. So in these cases, you could see that there are, so just a minute. Yeah, sorry for the problem. Yes, and here we look at scales, which is very, very important. So the type of the investments required, the type of the assets or infrastructure required, and the type of consumers whom this product would be catering to. So in these cases, if you see, we are navigating from the preliminary rounds into advanced API molecules, which could give us the targeted medicine for such type of ailments. Now, such type of resources done. We at IAC Bangalore, we have actually devised uh, uh, algal nutraceuticals, where many of these molecules from algae could be a precursor to drug. So this is where we have did our research in ISC Bangalore. So this is also important to see how the translational pipeline is completed with the help of the clinical research landscapes in India. So here India is becoming one of the global powerhouses in the sector. So uh, I just mentioned EWRG, where we are pioneering to use algae as factories for commercialization, along with partners like CSIR, CSRI, and NIOT. So these organizations are leveraging India's massive 7,500 plus kilometer coastline, whether these could be as grounds on which such type of seaweeds could be propagated, and a number of clinical trials are underway registered in India for algal interventions. Every year you could see such type of enterprises or such type of interventions are rising. Our vision is pretty clear. It is to position India as one of the global hubs for a blue economy, or we could say a blue pharmaceutical, a blue pharma, turning our sunlight and sea into life-saving medicines. Well, so now we looked on to the very basics of algae in terms of nutritions. We'll now would like to move forward nutritions as in the linkage of algae to nutritions, pharmaceuticals, and nutraceuticals. So here we are showing you a particular case. This is the first of its kind of study that we did at such large scale, which is 20 plus hectares of algal farms, and we looked at the very nature of the algae, its scalability. So you could see these are the studies which were underway the first time in India way back in 2010 to 12. This is the time where we looked at can we actually design algal single cell proteins from agricultural farms, which also has a blend of wastewaters into it as a potential feed for consumptions. So this is published in this particular research communication, which is protein byproducts by Elsevier. So definitely one can go through it for the details. So as we have told about, so this very particular manuscript describes the environmental burden of greenhouse gas emissions, untreated wastewater, and how do we balance it with a massive production of algae. So the algae production is a win-win here, because it caters to pollution abatement by reducing GHG emissions and treating wastewater. At the same time, it also gives valuable proteins for as a cattle feed or as an aquaculture feed, and if it is purified to grade 1, it could be also used as single cell proteins for human consumptions. So here we are looking forward to a paradigm shift where this type of carbon, nitrogen, and phosphorus that are predominantly found in such type of agricultural farms and wastewater that could be renewably converted into high quality proteins. So in this case, we had an year-long study where seasonally algae were sampled, the water quality was monitored, algal seasonal productivity was measured, and it was extrapolated for the entire treatment plant. And then we calculated what would be the potential of this algae to fix carbon, convert that into protein, and what would be the likelihood of the production at this particular scale, which is many hundred tons, for enrichment and for usability of such type of algal based single cell proteins for local people, and that could be distributed to market. So in this case, we are comparing yeast, bacteria, and fungus, which are predominantly used as sources of protein, with algae, which is euglena. So you could see that the protein content was 40 to 60%, which is and the protein content were of high quality. They had lower nucleic acid risk. If you see, the nucleic acid contents were low, so they were having a better harvestability compared to others, where 40 to 100 micron size algae were bigger enough to be captured by autoflocculation without even adding any chemicals or using any mechanical instruments. And finally, you could see the very quality, the digestibility, and the palatability of algae, where there is no cell wall. There is an easy enzymatic decomposition, which is much better than proteins from dairy like whey or casein. So here, this particular case study gives us a unique combination of a high protein, low toxicity, and a superior digestibility, which could be a candidate SCP, a plan that was set several years before as one of the movements. So post this study, there were a number of studies on single cell protein. So this could be one of the pioneering studies that gave a roadmap to scalability and commercialization, which is possible from such type of agricultural and waste farms. So this was actually conducted at Mysore with the help of the city corporation, where we had a project. Now, this particular organism, Euglenoophyceae, is an architectural genius, is because they lack a cell wall. They have a huge paramylon bodies, which is very unique. So they have a lot of fixed food. So they have quality lipids, a lot of proteins, and also pigments, which is very, very important. And they have a flagella with which they move. So these are highly sensitive to lights, and they are locomotory in organisms. So this is where why is that the productivity is very high, is because they could actually grow in mixotrophy, where they can take cells carbon dioxide directly from atmosphere as dissolved carbonic acids, carbon dioxide, and bicarbonates. They could also take dissolved organic carbon. So it has both heterotrophic and the phototrophic way of osmolality. They are also at times phagocytic in nature. That means they can ingest particles. So this gives them a brilliant edge over other organisms as a massive single cell protein source. This is how the experiments are. I would not take much time. You could see at the behest of the carbon that is coming down with respect to time, the biomass grows in, which shows a hand-in-hand relationship of carbon abatement and a lot of SCP production. This is the type of the phototaxis that happens. So daytime, you could see these algae are on the top layers of the pond. So this is around 4 meters deep. This is a Vipuram treatment plant, and here in the night time they settle. And the way is that when they settles, you have to switch on the sludge pump, and the pump actually draws all the settled algae. In this case, we hardly spend even 1/10 the amount of energy that is required for centrifugation to collect the algae. So this gives us an economic win, is because we are not adding any chemicals, we are not investing more of energy, and we have a better harvest of this algae. So this gives us a roadmap for economic translational framework, where we have the nutrition, which is mixotropic to phagotropic. They have the phototaxis, which is the diurnal dynamics of algae that helps in harvesting, and the very digestibility and palatability, which is because of no cell wall presence. So in figures, to sum it up, the commercial scale validation has come about to a 10 hectare VPRM integrated plant. So 2 units is 20 hectares here. So in this case, we have two facultative lagoons. So the yield matrices so roughly around 25 million liters per day. That is the type of volumetric loading. The biomass density could be as high as 0.35 grams per liter. And then, so the surface productivity is more than 20 grams per meter square per day. So this gives enormous opportunities for marginalized farmers or technical people to scale up this to higher levels, even at with the help of agricultural waste or wastewater or municipal wastewater. So the annual single cell protein production could be as high as 260 tons of high grade proteins. Now, this is a comparison of this particular study that we did for the very first time in India with other studies. So where we have compared it with the traditional raceway ponds, the photobioreactors. In Australia, they were having Dunelli and raceway ponds, the European spirulina ponds, and the commercial chlorella ones. If you could see here, we by doing a systematic techno-economic assessment, the cost per kg of wholesale biomass comes to roughly around 73 INR per kg, which is cheaper than what is actually available in the market today. So here, in this case, if you also order a packet of algae today from Alibaba or any sources, you could easily see they cross 1,500 rupees for every kilogram. However, if we are actually growing algae at this particular scale, at this particular rate, we will be definitely offering a better competitive prices, even 1/10 the cost of what is being available today in the market. So the takeaway from this is a standalone single cell protein production system, which is really efficient and cost effective, and where you do not really have to search for land and fresh waters, and it only can happen with agricultural runoff or a blend of agricultural runoff and municipal wastewater. This is the operational validation, where you would see at various stages how is the algal values getting added, and this is a cumulative, where you have operation and maintenance, which is all in negatives. That shows the amount of the capex and opex that is being invested. And then when you have the algal production and all, you could see that the benefits are where we have a positive thing. So water treatment, algal SCP production, and you could actually sell the recycled water. So that gives us tremendous benefit. And now you could see the losses are more or less compensated by the benefits, which accounts to roughly around 5 millions per year. So this is the net annual profit of the treatment plant that we have. So this is where one can actually vision this as cell biofactories for earning a lot of revenue. So this is where you have the pollution that has come down, which is reduction in total suspended solids, turbidity, biochemical oxygen 82%, chemical oxygen are roughly around 80%, phosphorus and nitrogen you could see. So these are the benefits of using algae, where they not just grow, they also treat water. So therefore, this particular model could be a commercial paradigm for urban infrastructure, where every urban household or a community could be juxtaposed to such type of algal farms, where they could have a revenue model which is from waste, and the entire community can get benefited by market opportunities from single cell proteins. Of course, like one has to go forward with legal clearance and delineations. So there are various regulatory bodies like FSSAI, where you actually go for checking the health supplements and functional foods. They're even more stringent, QA/QC, record maintenance, and appraisal teams like the drugs and the active pharmaceutical ingredients testing. Here, this governs various important molecules that have explicit therapeutic claims, and therefore have a very rigorous quality check in this case. To highlight these processes more, you could see here the food pathways. Very basic preliminary analysis on food and nutritional supplements are done, whereas the medical pathways, the therapeutics and APIs, actually need very clear definitions to prevent gray areas. And in this case, both the pathways for food and the therapeutics are very rigorous. and they live up to the standards and now are driving the global expert readiness in this country. So this encompasses a lot of food, nutraceuticals, and drugs put together to be assessed by two different types of regulatory bodies. So one has to be very, very clear about the type of the characterization, the nature and the type of the material and the characterizations. So here you need very precise molecular identification and detailed structuring profile. If we are going for algae-based, API, then we could actually see whether the same things could be reproduced in the next season. So here stability comes into play, where if we are doing experiment, it has to show a proven shelf life, and there has to be a molecular integrity for which it can be saved and used for purposes in future. And the most and the foremost important is safety and efficacy, where it has to land up in various types of preclinical and clinical trials before it has to it ends up as a human drug ingredient in the system. So this is where you have the certification, which is very important according to the Drugs and Cosmetic Act 1940 and 2019 rules. Well, here the problem here could be many folds. If you have two different conventional systems, indoor and outdoors, although indoor is a higher production cost and infrastructure cost, but the quality is better. So in case of open ponds, we actually have a lower quality, however the productions are, so there is a trade-off between the production or the yield better versus the quality here. So in this case, the technology readiness levels are different for these particular scales. However, in Indian systems, being a tropical economy with a higher intensity of sunlight of 5 kilowatt hour per meter square per day, so this is the, so we actually see better trends and better practicability for open ponds than photobioreactors, where it could be less costly, it could be easier to scale up. So target output could be spirulina or euglena, and categorically they have lower risks because of UV, which is inducted by the sunlight into it, compared to the European systems, which are mostly to do with photobioreactors and indoor cultures. So the harvesting hurdle could be one of the most important criteria for economic costs and calculations, or the techno-economic profile of algae to be marketed to the next level. So in this case, India is already producing a lot of biomolecules, a lot of APIs, and today is one of the leading producers of organic spirulina and chlorella that is being supplied to a number of different countries, like in Northern Europe, in US, and in Japan, and Middle East, and so on and so forth. So now we, with a great, vibrant, enterprising environment, with like 35 plus companies, are world's largest exporters of organic spirulina and chlorella. And then we need to undergo certain type of trust vectors like global certifications, the agreement or the certificate of analysis that verifies there is no heavy metals and environmental toxins in this. And then you have the socioeconomic impact, which is very important. So are we involving people and imparting employment to that is also very much important. So with such type of integrated techno-economic assessments and a sort of a vibrant entrepreneurial environment, I think we can go far ahead with SCP cultivations with the plans that I have shown you earlier. To start with, like the raw biomass, concentrated extracts, and purified APIs, this is actually the economies for scale, starting with raw biomass, making it more affordable, then tagging in a right kind of resource people for concentrated extracts, where you have a mid-tier pricing. So there could be basic pricing for raw biomass, a mid-tier pricing for the concentrated extracts. However, when you assure that your APIs levels are 99% pure molecular compounds, it could be premium, sometimes costing lakhs. So astaxanthin and other pigments at a higher purity could cost lakhs for every ton of the biomass that is being produced. So biomass leads to pigments, and pigment would lead to a lot of revenue. So this is the economy model at various purity levels, and this ensures a clinical nutrition, cost effectiveness, resilience to pandemics. So we make ourselves very, very strong, and where algae plays a pivotal role in treating diseases like pandemics, helps us to develop our immune systems, gives us a lot of global molecules for the agility in the body, makes us more immune, provides more immunity, and makes us less vulnerable to a lot of different types of disease that we see. So so algae becomes a win-win conditions in terms of this type of food, feed, nutraceuticals, and pharmaceuticals. So this is a healthy planetary loop. So where we are looking for multi-stage advantages, right, from carbon sequestration, phycoremediation strategies, aligning ourselves to actually cope up with most of the sustainability development goals. So be it goal 0, which is zero hunger, or goal 3, which is good health, or goal 13, which is climate action, and finally the very important reduce recycle policies, where we have a zero discharge or a zero waste policy. So put all these things together, we can ensure a healthy planet by imbibing such type of strategies. And this particular slide gives us an idea of phytopharmaceuticals, which is an integration of our Indian knowledge system, modern biotechnology. Because of paucity of time, I have not talked more into the aspects of omics technologies or CRISPR technologies for better algal engineering for production of targeted compounds. And so this particular environment needs integration from IKs, from modern biotech, and from progressive policies, which is from the NEP 2020, where Department of Science and Technologies is actually contributing and enhancing on the interest of cross-disciplinary type of collaborations with Ministry of IUS between biologists, industry, and a lot of scholars who are today students of Indian knowledge system. This is the type of the innovation horizon today. So we are at TRL level 4, 5, and products which are already in markets, gross products are TRL level 9, 10. So this is where a lot of smart technologies which we say as Algae 4.0, AI driven algae, could be actually deployed here. So here a lot of training based models, deep learning techniques could be used for producing designer strains which is engineered for a higher production and specific drugs targeting. You have a lot of polymers or materials developed which could be aided from nano algae delivery. So some of our students are working on polymers for drug delivery and for environmental regulations. You have a lot of scope for pharmacogenomics, where a lot of nutritional protocols could be tailored to specific algal supplement profiles. So it could be carotenoids and so on and so forth. And this is done with the help of an algae's unique genetic makeup that could be engineered with the help of CRISPR technologies. And then a global capital acceleration, where a lot of investments can happen because of this type of entrepreneurial environment that is there. Make in India and several other programs where as a country, India is pushing forward to a lot of products and processes development within the country for movements like Atmanirbhar Bharat, where a large-scale contribution is also done by UNESCO and WHO under global headers of sustainable technologies and blue biosolutions. To sum up, Algae for Life, here we have talked a lot on the connectivity of algae with the origin of life, bridging nutrition, nutraceuticals, and pharmaceuticals for a better global health on account of observing and celebrating the World Health Day here. So initially we talked about the global health context. So where such type of provisions, where we have a mass production of algae, could help in addressing problems of hunger and malnutrition at the same time, enhance food security, and will be a single positive move or solution for addressing chronic diseases. And algae could greatly help in this. So these particular lessons have been learned from Indian knowledge systems, which is from Sushruta and Charaka, comes as a Saivala Sanjeevani, where algae was once upon a time recognized as Amritam, or the divine nectar, or the most medicinally potential liquor that was used for medicinal purposes. Then we bridged various elements or the functionalities like nutraceuticals, pharmaceuticals, nutritions together, and looked at the algal global spread with the help of species like chlorella, spirulina, euglena, hematococcus, which could actually give nutraceuticals, pharmaceuticals, and a lot of nutrition. So here we also discussed one case study in Vidyaranyapuram where ISC Bangalore was instrumental in developing algal single cell proteins, which was fortified, which could be having a sort of an effort for fortification that could be used as a potential cattle, a dairy feed, or it could be used as a poultry feed, or it could be used for aquatic fisheries. Then we looked at the regulatory bodies like FSSAI and ESC, so global standard compliance, where we looked at the bodies helping in regular monitoring and assessment of key compounds at crude level or purified level. And finally, we bridged it together for developing a future roadmap where such type of systems could help thrive a circular bioeconomy by simultaneously addressing monsters in the environment. When I say monster, means the apparent problems like carbon capture, climate change, soil degradations, nutrient losses, evapotranspirational losses, biogeochemical cycle disruptions, and so on and so forth. So here, this particular roadmap gives us a platform to develop a scale-up strategy for global adoption of algae, and helps in restoring the ecosystem services. So this culminates today's talk, where we have been looking into the functionalities and potential of Saivala, the algae. So the bridge where the requirement is sunlight, and it can actually create life. So here algae stands up very tall in this particular framework, where it is capable of not just solving the food problem, the medicinal use, but also addresses climate sustainably. This is pretty much clear from the studies that we have taken, and also taking a great deep dive into our ancestral knowledge, the wisdom, and the Indian knowledge systems that gives us plethora of ideas, strategies to blend in modern technologies with our conventional medicinal route from Susruta and Charaka put together. And as a system, such kind of interventions will help in making sure that we embrace these very minute and tiny photosynthetic organisms to solve the biggest or the monstrous problem which we are addressing today in the 21st century. Thank you very much for a very patient hearing, and I would love to attend to any questions or queries that you people have.
Thank you so much, sir, for your very informative talk. Now, I would like to inform people, if they have the questions, they can ask in the chat box, or they can unmute themselves and ask the question. So there is one question.
Yeah.
Is there nanoplastics in algae as it is often found in the fishes?
Well, very interesting question. I think there are certain studies where there are actually chances of accumulation of nanoplastic inside algae. However, at a preliminary level, I think one must have to get into the details of the type of the behavior of algae, where algae could actually see that nanoparticles like that nanoplastics are involuntarily entering the cells. So this is debatable. I think one has to look at these aspects to make sure that algae still remains one of the healthiest food in nutritional aspects. However, a lot of our tests that we have done in laboratory have not shown that algae has been contaminated with nanoplastics. Yeah.
Okay, thank you, sir. There is one more question from Melvin. Given the growing importance of algae in pharmaceutical production, to what extent do cultivation practices impact surrounding aquatic ecosystems, especially in the terms of microbial community structure and nutrient enrichment processes?
Okay, so Tulika, can you please shorten the question?
Yeah, Sure, sir. So, Melvin is asking if, in the circumstances of growing the algae, what can be the surrounding impacts in the ecosystems, especially in the terms of in if how it will affect the microbial community and the nutrient in the ecosystem.
See, algae, we have talked as an environmental stabilizer. So wherever you have algae in the system, they take up nutrients like carbon, nitrogen, and phosphorus and give up the life supporting oxygen. So therefore, algae has been very prudently used as uh, an agent for bioremediation and always have been helpful to stabilize systems. So the very nature of pollutants would get defied, so it helps in easy oxidation. So and algae has given us the biomimicry way of advanced oxidative systems, where a lot of oxygen is actually helpful in treatment of pollutants, all the way. So from complex carbohydrates or hydrocarbons all the way to carbon dioxide, which is the most the most oxidizable form of carbon. So in this case, if I'm addressing the question properly, algae do stabilize the environment. They detox the environment. They helps in increasing the visibility through sunlight penetrations if photosynthesis is happening adequately, and push in a lot of oxygen. And at the same time, they stabilize the system by making a sort of a carbon, nitrogen, and phosphorus balance. Yeah, thank you very much. I hope I have answered the question. Am I audible? Hello.
Am I audible?
Yes, please. Yeah.
Yeah. So, sir, my question is like in continuation with Melvin about aquatics ecosystems.
Yeah.
What about built environment? Like nowadays, we see a lot of products. For example, there are some people, some startups selling tanks with filled with algae water,
Hmm.
claiming that they sequester a lot of carbon. Similarly, in your slides, you also presented one slide where the facade of building was covered with algae tanks.
Yes.
So, sir, like how this system works and how efficient it is.
Yeah, so there are a couple of
The
models you can
environment.
check. Yeah, you can check. I might be able to share you some links which are papers. So they have practiced it at a very small scale, which is through parallel plate reactors, which looks like a wall. So in this case, more is the surface area exposed to sunlight, higher is the growth. And today there are, a lot of membranes that could actually help in diffusion of carbon dioxide and nutrients selectively to these algal modules. We have to still check. However, there's a lot of potential is because once we plan this and we start implementing these things in urban infrastructures, there would be a radical shift in carbon dioxide absorption, which will be helpful. So this might not be sustainable at the moment, where we need to really find out particular platforms, polymers, where it could be scaled up so that they replace walls with such type of algal glass facades. However, things are moving fast, and with the development of technology, sophistication in materials, and a lot of membrane technologies, I think things would be very, very clear and practical in near future. I hope I have
Got it.
addressed your question, Utkarsh. Yeah, thank you.
Got it, sir. Thank you.
Thank you, sir. There is one more question from Ravi Sagar. What field does algae production have a better impact in, biofuels or fortified food?
So, well, if we are using algae for biofuels, we might be undermining the value of it. If you compare a liter of fuel compared to 1 kg of fortified food, you could see that fortified food costs much higher. So, if one wants to start up a business, would like to contribute to national economy, I think the nutrient supplementation, or the nutrients, whether it could be food or feed, nutraceuticals and pharmaceuticals is the way to go. You can look at the comparative cost between fuel and the feed or the food. So you could see that the value of food is much higher compared to fuel.
Thank you so much, sir. And Ravi Sagar has also mentioned thanks for the informative talk.
Yeah.
Sir, then next, there is a question from Divya.
Hmm.
Sir, you have spoken about the algal hydrogels. How efficient are they in crossing the biological barriers in our body? And also, can you please tell about the potency of these algal APIs and their target specificity?
Yeah, there are like hundreds of APIs. So, see, I'll tell you, these are lead compounds from most of the pigments, and this is where the type of the precursors that is required to initiate certain set of reactions are important. So, if you look at zeaxanthin, astaxanthin, based, or you could say the phyco-derived carotenoids and xanthophylls. So there are a plethora of APIs which are helpful for antioxidant and anti-cancer properties. So in this case, the specificity of this type of APIs is to do with the very nature of the algae from where it is collected and the type of the interaction it is doing with the help of the molecule of target. So which is mostly done by the type of bioactive peptides, docking them and provisioning them into the drugs, and finally stimulating them with the help of molecular modeling and drug design. So this is a sort of a protein engineering, wherein when you say bioactive peptides, they are not entire proteins. They are several amino acids. You could see the 3 amino acid also could make the one of the smallest bioactive peptides. So it could. So in this case, the choice or the selection of the type of the bioactive peptides which could be one of the important ingredients to API is also very, very specific. So one really cannot have the entire things put together. However, when we talk about let's say anti-cancer properties, ACE2 regulator. So ACE2 regulator is dependent on the widening or the narrowing of the blood vessels. If you see, so this is where you can actually work a lot. So bioactive peptides, which is 5 to 7 or 12 amino acids, have been workably very effective in as ACE2 regulator, which is for constriction or dilation of blood vessels to manage blood pressure issues, hypertension. So similarly, when we actually go shift this to the type of gut digestion and its interaction with the submucosal wall, there are different kinds of ingredients there. So one has to look at what cases we have, and then one could find out the interactions between them. I hope I have answered your question.
Thank you, sir. There is next question from Paras. How can algae cultivation can be implemented in uh, al- in the hilly areas as sustainable and economically viable livelihood option and harmony with natural ecosystems?
Oh yes, that's a very interesting. We are actually going for a workshop very shortly. On 9th, we have a workshop at Kullu. So where all the farmers would be around, and with the help of some NGOs, we are going to show them how do we do that. So what exactly he's asking. So here, of course, it might be challenging, but wherever you find water and nutrients, you can always have them. So a little bit of provisioning of maybe a structure is required, and once you have the type of structure, it could be ponds, it could be narrow channels, or it could be some type of containment which is necessary. And of course one could grow them and harvest them at higher altitudes, because you could see algae grow in extremes of environments, and then that could actually lead to. So this particular interaction that we are going to have with farmers is mostly algae as single cell proteins for an aquatic fish feed, a sort of entrepreneurial journey that we have started. So this is with the funds that have been sanctioned from NMHS, a National Mission for Himalayan Studies, where we are looking at districts of Kullu and Mandi, these two places, Kullu and Mandi, where we are going to demonstrate these things. Yes, this is very, very, very much possible. Even at more higher altitudes in Leh Ladakh also, we have witnessed a lot of algal species that are being growing. So one has to really channelize nutrients to grow them up, because we have plethora of sunlight around these areas. And one could easily start a business or a startup or or a sort of an investment with such kind of reactors.
Sir, Can you specify which all the species can be prioritized in the lower Shivalik range?
Yes, very good question. We are now looking at, so my own lab is actually growing a lot of, you know, cyanobacteria. So cyanobacteria, which is Eulothrix and spirulina. We also have seen bacterial growth which is happening in a slightly warmer environment, which is to do with chlorella. So and higher the altitudes we go, we see a lot of variation of filamentous cyanobacteria. So if it is this particular range where we are not very high, so let's say we are in the Mussoorie range, which is the lower Shivaliks, so which is roughly around 1.2 kilometers from the mean sea level. So in that range, I think very easily one could actually grow cyanobacteria and harvest them for whatever use.
Thank you, sir. Next question is from Divya.
Yeah.
She is asking about marine environments as they are very dynamic, which will be a major challenge in the product composition and how to maintain its consistency.
Yeah, a nice question. So there could be a daily dynamics, there could be also seasonal dynamics. However, we are talking of seaweeds that could be tagged to land masses. So in this case, I forgot to show certain slides where one of our friends who has opened up a company, and he was also a partner to PepsiCo some time back. His name is Nelson. He's a pass out from IIT Chennai. And so they are actually in Mandapam and Rameswaram coasts, they are actually growing seaweeds where they're attaching these seaweeds to bamboo rafts. So to make sure that the algae are not getting into different zones, so you say they are euryhaline, so with a homogeneous salinity and nutrient levels, they have actually tagged at the shorelines with ropes to bamboo rafts where they are floating all the time. So in this case, they actually harvest it every season, and you could see with they start with grams, they harvest tons. So this is where the challenges of different types of nutritional zones and the diurnal and the seasonal implications could be reduced. I think we can actually have another session on this, where how do we go about propagating or cultivating algae in shorelines could be one of the interesting questions that we might address in future. Thank you very much for a very good question. Is there something else in this question also,
Yeah.
Tulika?
Not in this question, sir. Coming back to the mountains from the ocean again, then again to the desert. There is a follow-up question to your earlier answer. What is the viability of this in the desert ecosystem like Rajasthan? Does hot and dry weather promote growth or retard algae growth?
Yeah, so this actually depends on the depth of the culture. So more is the depth, the higher would be the growth, because as you can see, whenever water is becoming brim, you could see that in shallow ponds, you could see there is a sepsis happening is because of algae drying out, and this is called a algal burnout, which is because of concentration of the nutrients due to evaporation, and then algae and bacteria of anaerobic order growing and taking over the algal community. Yeah, if we are assuring that there's a regular supply of water through channels, even in desert ecosystem like the Aravallis or the Rajasthan and Gujarat, a couple of parts of Gujarat, you can have a very decent algal. There are many studies where they have conducted a decent algal growth even in desert atmosphere. And in these cases, one has to look forward to the kind of environment. So if I say desert land, let's say the Kutch regions in Gujarat are very effective in growing halo-tolerant algae, where there is no competition. Absolutely, one or two important categories of algae grow that are osmotolerant or halo-tolerant. Secondly, in Rajasthan, you could actually see that with the type of the intensity of higher sunlight, there are ample provisions of green algae to be grown at higher intensities, because is the right environment. A high illumination and a warm environment which could actually trigger green microalgal growth in those regions. So and then I would also like to give you a particular snapshot of the publication that we had earlier on algal niche and habitats across different depths. So once you see that there are the higher depth, so you could see that algae orient themselves into different zones. So there are green algae on the top zone, and in the bottom you have cyanophyceae. So cyanophyceae can even take infrared. So we are actually doing some experiment in the lab to see that is it true that algae can grow in non-visible radiation regions? If that is so, then there is no requirement of visible light. Even scattered light and IR will be sufficient for. So this is a hypothesis that we are testing, and very soon we will be coming out with a sort of a document where we are strategically provisioning green algae at the very bottom where there is no chances of wavelength. So it could be a multi-tier cultivation where the top tier is illuminated zones, semi-illuminated zones, and bottom zones are the unilluminated zones where even cyanobacteria could propagate. So this very much depends on the depth of the water, the temperature or the heat sensitivity of the water, and the climate of the region. Thank you very much for this question.
Thank you, sir. And there are thanks from Paris, Divya, Ravisagar, and Melvin for your informative
I
answer.
also thank them to very patiently, listen to my talk, although it was a bit longer. But I wanted to touch upon most of these areas where we could have an integrated way of, asserting this resource for our revenue generation machinery for the nation. Yeah, thank you very much for the invitation, and I thank all the people, the audience, the organizers for a very patient hearing. I would specifically like to thank. Uh, TVR sir and the various group members and other people who are a part of this fraternity technological platform for regularly giving us opportunities to present our ideas, thoughts, experiments, and results in this very widely shared public platform. Thank you, and hopefully we'll meet sooner to discuss upon algal growth in coastal ecosystems and how to nurture the technology to tier level 6 and 7. That is technology readiness level where we are into the pre-commercialization stages. Thank you very much for the opportunity.
Thank you, sir. And now I'd like to invite TVR sir to conclude today's session.
Thank you, Durga, for a very informative talk. You know that we did a field work in Sambar Lake where we come across the pink color algae, which also the many industries are extracting it,
Yes.
especially the pharmaceutical industries. Already the industries have understood the potential of this
Yes.
algae. And also, if you recall, during our field visit, where you were there with me in Ladakh, we
Yes.
saw the purple algae. At the
Yes.
time we were wondering what are the beneficial aspect of that.
Right. Right.
What you covered today is very exhaustive. I think this is a candidate for you to write a series of articles in resonance and current science. In resonance, when you write, it will make the many youngsters to take up this domain for a higher research. And today, the questions what asked by these youngsters, most
Wonderful
of them
question.
are in the age group of 20 to 25.
Yes.
You look at all of them were in that the bandwidth. That shows that there is a lot of interest on this in this domain. So probably I think you should start writing in resonance and current science, maybe
Yes, sir.
one lengthy article in current science on this aspect. What you did today, the presentation, I think the same schema work for the current science. And also some of the specific thing you can take it up in resonance, and they'll also publish it very soon.
Okay.
That will also give you an edge, because that resonance and current science will go to all universities and colleges in India.
Yes. Of course, sir.
Okay.
Surely I'll plan
Okay.
to do that, sir. Thank you very much
Okay.
for
All
the
the best,
support and involvement.
Durga, for an interesting talk. Thank
Thank you.
you.
Thank you so much, Mr. Sir.
Okay. Bye bye.
Thank you. Thank you very much, everyone. Thank you so much,
Yeah.
and
Yeah.
good night.